Once upon a time before GPT-4o from Closed AI, we had GPT-2 is a good chatbot on the LMSYS Chatbot Arena.
What the hell is even that?
Chatbot Arena is a free-to-use data harvesting project created by UC Berkeley. When using their site, we get 2 LLM-generated responses from 2 random models out of a list of whatever leading language models the developers are currently testing. This obviously allows for a new method of benchmark testing LLMs against each other. But the real value in this project for UC Berkeley is it can be used to motivate Closed AI to give them funding so that they can just give their new models to this chatbot arena to test it and create fine-tuning datasets of only the best responses and the preferred responses from the enthusiasts using these models, rather than having to pay for developers in a third world country to rank the responses from these new language models. Closed AI can just use us enthusiasts for our free labor to create even better fine-tuning datasets. In this video, I will show you how to create your own LLM arena to stream responses from the 4 leading LLMs at the same time after each prompt input. For us regular users of generative AI in 2024, we all know that certain models will perform better on certain prompts. Instead of manually checking each of our prompts on each LLM's website, let's create our own website to save us time by streaming the responses from all of them at the same time inside of one web interface. Like the OG Chatbot Arena application, this web application will have the ability to upvote our favorite responses in the front end, which will make the web app store the prompt and upvoted response in an SQL database on the back end. That means by building your own chatbot arena, instead of your time interacting with the AI being used to create datasets for UC Berkeley to fine-tune LLMs for big tech, we can create our own datasets of only the best responses from the largest pioneer language models. With our custom dataset, we can fine-tune smaller language models capable of running locally without an internet connection and full data privacy, effectively enabling a massive language model to teach a small language model how to respond like we want. In all of the previous videos on my channel, I have shown you how to apply AI in new ways using Python scripts that you can run from a command line interface. In this video, I will introduce you to Django, which is the Python web framework for creating production-ready full-stack web applications. Unlike 99% of Django tutorials online, after we get our web app working in a Django development server locally, I will show you how to securely deploy this web app on a production virtual private server. This will allow you to use the site from any device connected to the internet instead of just playing with the site locally on the device that you develop from. To get started coding your chatbot arena, you will first need to have Python 3.10 to 3.12 installed on your PC. Like most of the videos I upload to AI Austin, this will be an in-depth coding tutorial. If you do not have the patience to go through a video tutorial and just want the source code for the programs in my videos, they are available weeks before the videos go live here on YouTube in the pro channels of my Discord server. By becoming an AI Austin Pro member today, you not only get early access to my source code, but written pro tutorials that has every command we run and all of the code we create in each of my videos. As just one mortal man, my videos take an insane amount of editing and coding time to create engaging AI programming tutorials that can be digested from people with little to no programming experience. My pro-written tutorials, on the other hand, take me far less time to create, as the pro tutorials are just a refinement of my actual development notes that I use to build these programs before even recording the first second of my videos. I've also started adding a lazy pro tutorial for each of my new videos for anyone that doesn't care to understand or learn about the code and just wants to run the apps as simply as possible. To start your AI Austin Pro membership, click the Buy Me a Coffee link in this video's description to join today. For everyone already a part of my pro membership, your support is what makes it possible for me to keep uploading to YouTube. Thank you for supporting AI Austin. Now back to the video. Before we do start coding out a full stack web app, we need to create a simple script to stream the responses from each of the 4 leading LLMs in response to each single prompt input. To do so, we will install the Python libraries to generate our responses from each of their APIs. Open a terminal window for Mac and Linux users or a command prompt window as admin for Windows. Then run these 4 commands to install the Python libraries. Inside of a code editor, create a new file called llmfunctions.py. Inside of this file, we will import the libraries for each LLM API. We can then configure our connections to the APIs by passing our API keys and the desired LLM configuration settings. After that, we will define a function for each LLM to stream the responses. Lastly, we can request a prompt input in a while true loop and then pass the prompt to each of the LLM functions. When you run this Python script, you should be able to type a prompt input and then the program will stream a response from each of the LLMs one at a time. Since this is a Python script, it makes sense to not stream async, meaning not all four at the same time, since the user interface doesn't allow for it. For the web app, we will use async streaming to generate our streaming responses all at the same time inside of their own response windows. Once we have all of our LLM functions working, we can install 3 more Python dependencies for our Django web app. Run these 3 commands to install the Django, Channels, and Daphne Python libraries. We can start the Django project by running this command to the Django admin, calling the start project command and naming our project chatbot_arena. Then we can change our directory to that folder by calling the cd chatbot arena command. To explain how Django works without going too far into detail in this video, in Django, we can create projects. When we create a Django project, you can think of this as the entire code for our website. At first, it gives us some template code to power a website. Now, within these websites, if we want to add things like a specific app, like a chatbot arena, we can add a Django app to segment all of the code for that web page or feature to our website. To create your Django app, run python 3 manage.py start app, naming it arena_app. Make sure you run this command in the main chatbot arena folder, since it is running the start app function from the manage.py file to create the Django app. First things first, we need a front-end web page to give our web app an interface that the users can interact with from their browsers. That means we need some HTML, CSS, and JavaScript. Let's start with a basic implementation that we will iterate on as we build out our web app further. For this implementation, inside the Arena app folder, create a folder named Templates. Inside the new Templates folder, create another folder called arena_app. Then create a file in the last folder called LLM_stream.html. Start by adding an HTML tag and then within it a head tag. Inside of the head tag, add a title tag and set it to Chatbot Arena. This tag will set the text inside of the Browsers tab to describe the web page. Outside of your head tag, in the HTML tag, add a body tag. First, we will create a text input field and a send button for typing our prompts. Then add a div for each of the 4 models' responses. Now, in order to make your web page actually interactive with the ability to display the responses received from the backend server, we need to add some JavaScript to our front-end code. Below the title, in the head tag, add a script tag. Declare a socket variable and set it to null. Then create a function named connectWebSocket. Inside of your connectWebSocket function, update the socket variable to equal a new WebSocket connection, setting it to the WebSocket URL that we will set later in our backend code. Now we need to define a few built-in WebSocket event handlers. The onOpen event logs when the connection is established, while the onMessage event handles incoming data. When a message is received, we parse the data in the front end and update the correct model's response box by appending the new tokens. We can also handle connection issues with onClose and onError. If the socket closes unexpectedly, we can trigger a reconnect after a short delay. If there's an error, we'll log it and close the socket. With our connectWebSocket function written, outside of the function's brackets, we can call the function every time the window, aka web page, loads. Finally, create a sendPrompt function that will send the user's input to the backend and clear any previous responses from the 4 model response areas in the front end. Since this is a web application, we will be modifying multiple code files throughout this video, so always save your files before we move on to the next code file. Now that we have some HTML code, we need our backend server to be able to route this HTML file to be sent when we visit the main web page. To do so, open the views.py file in the Arena app folder. In a Django project, you can think of views as the Python file running on your backend server that your front-end JavaScript has the ability to send requests to. Basically, the views is the API for your front-end code. In this case, we need a view to display our homepage and return the correct HTML file every time we visit that URL. To create the homepage view, we can define a new function, aka a view, named LLM_stream to take a request as an input parameter. Inside this function, we will simply return the rendered LLMstream.html file that we previously created. Now let's copy in the LLM functions file we created at the start of this video to our Arena app folder. First, let's import the logging library, then initiate the logger. In each function, we will add error handling. Before we fully implement streaming responses, let's first modify each LLM function to accumulate the stream chunks from the LLM APIs and return the full response to our front end. For the Arena web application, we can also remove conversation handling from all of the LLM functions. After each call to the LLM APIs, if the response content is empty, return no response generated. Now that our LLM functions are ready, we can integrate them with Django WebSockets by creating a consumers.py file in the Arena app folder. Feel free to pause to copy in this code, but let me just explain it in my best attempt to not make a noob's brain hurt. The consumers.py file tells the server how to handle real-time communication. In this code, LLM consumer listens on our server for prompts from the client, aka our LLMstream.html file. Next, LLM consumer processes the prompt using the LLM functions and finally sends back the responses over the WebSocket connections to our client. To power the consumers.py file, we need to create a routing.py file in our Arena app folder, which creates the URL path for the WebSocket's connections. Now that our app files are set up for the WebSocket, we need to modify a few files within the inner Chatbot Arena folder. The first file we will modify is the ASCII.py file. ASCII in web development stands for Asynchronous Server Gateway Interface. By default, a Django web app uses WSGI, aka the Standard Web Server Gateway Interface. Inside of this file, we will import a few more libraries to power the ASCII app. Then inside of the application variable, we will change it to be the protocol type router class, setting HTTP to Django's built-in getASCII application function. For WebSocket, we will use the auth middleware stack, which will route the URL for our WebSocket as set in the routing.py file earlier. Now we can update our urls.py file to create the URL paths that we visit in our browser for our web pages. Here we can import our views from the Arena app. Then we can add a URL pattern, setting the path as an empty string, which will be the main page to the website. When a user visits that main page, call the LLM stream view. Next, we need to update the project settings.py file. Inside of the installed apps list variable, add channels and Arena app. Below the WSGI application variable, create an ASCII application variable to use the ASCII app that we created earlier. Then at the bottom of the settings file, add a channels layer dictionary variable to set the WebSocket channels. Then finally, add a logging dictionary variable to set up our error logging settings. At this point, we have all of the code for our initial web app. Let's run a couple Django commands to start up the web app on a local Daphne server. First, we can run the Django migrate command. Then we can start up the Daphne server using our ASCII app. With the server up and running, inside a browser, we can visit the site on our local host at port 8000. As you see, the site definitely has some work to go, but if you've done everything correct, you should be able to send a prompt and get a response from each of the LLMs in the front end of your browser, letting us know that the back end and front end code is functioning at this stage. The next step will be to implement asynchronous streaming for each LLM's response from the backend to our front end to speed up response latency for our web app. Start by opening back up the LLM stream HTML file. Inside the connect WebSocket function, we need to add some code to our onMessage handler. First, change the second line in the handler to be a const variable of response element. Now we will use an if statement to first check if the status from our WebSocket is an error message. And if so, show the error message from that LLM in the chat window. Else, if the WebSocket status is streaming, we can add the data chunk to our response element. Then within the send prompt function, we can modify our clear response calls from selecting the inner text to now select the inner HTML. Save the HTML code, then open your LLM functions.py file. Let's first remove the response strings from each of our LLM functions. Once the function checks if there is chunk content, instead of adding the content to the previously existing string, we will yield chunk content. Yielding the chunk will effectively send that chunk over the WebSocket to our front end. Once the chunk is received by our front end JavaScript code, it will be added to the LLM response window. We can also remove the if not statements from the functions as well as the return statements for our previously existing response strings. Now, instead of using the logger to handle our errors, we can delete the logger and logging import statement. Then we will simply yield any error messages, if any, ever occur over the WebSocket connection. Save the LLM functions file, and now open the consumers.py file, which will be the last file we modify to implement our streaming over the WebSockets to our front end. In here, let's remove the logging import, the logger, and the 3 logger calls from our code. We will also remove the import for sync to async, and now import async IO. In the disconnect function, we will now run a pass statement. Then we will remove the send LLM response function to be replaced with a new function named stream_LLM. This function will take self, response generator, and LLM name as input. Inside the new function, start a try statement, then create a for loop iterating through each chunk in response generator. The response generator input will be a function called to one of our LLM functions. What that means is here we are looping through each chunk received from the LLM function call. Using an await statement, we'll send the chunk formatted in JSON to our front end through the WebSocket. Then we'll call async sleep for 0 seconds to make sure the send call finished running. Next, we can set our accept statement to send any error messages to our front end if any ever occur while streaming our responses. Now within the receive function, we'll remove our current calls to the LLM functions and create a new list named tasks, which will be the function calls to our asynchronous stream LLM function. After our tasks list, we can run the tasks asynchronously by calling the await async IO gather function, passing the tasks list as an input parameter. Save the consumers.py file, and now we can start back up our Daphne server, and we'll see our web app now has asynchronous streaming for each LLM's response. We now need to style our web page to look less like shit, and now style it as shown at the start of the video. Open the LLM stream HTML file. Above the script tag, add a style tag, which is where we will add the CSS for our web page. Since CSS is something most people learned in 8th grade, I won't be explaining how the CSS works in this code, but this is the code that will stylize our front end and what you will change if you want to stylize your site differently. Then within the body of our HTML, we can add all of the classes to link our CSS to the correct elements in our page. Save the HTML file. Now when we start back up our server, our site has a clean dark mode interface with a 2x2 grid of the response boxes. With the basic styling done, let's add some visual feedback in the front end that our backend is generating our responses after we send the prompt. For this, we will implement a loading circle in the send button after we click it until the backend finishes streaming each response. In our HTML file, we can add some CSS in the style tag for the loading circle. Then in the script tag, create a new variable named completion count to equal 0. Inside the connect WebSocket function, after checking if the status is streaming, instead of adding that data chunk received from the backend to our response box, check if it does not equal complete in curly brackets before adding that chunk to the front end. The complete token is something we will implement later in our LLM functions to send after the response is completed generating. Else, it is the complete token, so we can increment our completion count variable +1. Effectively, this allows us to have logic in our JavaScript to track how many responses have completed generating to know when to remove the loading circle. After incrementing the completion count, check if it is equal to 4, then we will set the inner HTML to equal send, setting the button to only display send and not the loading circle after it is finished. In our send prompt, we can modify our send button's inner HTML to be an HTML div with the class of loading circle as we set in our CSS. Lastly, add an ID to your send button. Save this file, then open up the LMFunctions.py file. Within each of our LLM functions, after the for loops have finished, we know the last chunks were generated from the APIs, so we can yield the complete token in curly brackets. Now the site will have a loading circle displayed in the send button every time we send our prompts until the last chunk has been generated from the LLMs. Now, as many of the regular AI users know, most LLM responses are generated in Markdown format. These hashtags, dashes, and more formatting info in our raw text outputs in the front end are actually Markdown styling code that, when displayed in a Markdown viewer, allows for a clean text formatting document. That's why when you interact with a large language model through a site like ChatGPT or Claude, your responses are cleanly formatted with headings, list, and segmented code blocks. Our responses are currently generated with Markdown styling information, but our web app uses CSS styling and not Markdown, which explains why adding the raw generated text from the LLMs to the response windows does not apply any of the styling in our front end and instead shows the Markdown styling code. So let's implement a system in our front end code to check the responses from the LLMs for Markdown code and then convert it to styling with CSS before adding it to the web page response boxes. Back in our LLM stream HTML file, let's first import the marked JavaScript library above the style tag. When we visit the site, the library will automatically be downloaded in the front end of the browser. Next, we can add the CSS styling for our Markdown responses. The way these styles will be applied to our responses is when the JavaScript parses the response for Markdown headings, for instance, it will convert the formatting to an HTML heading before displaying it in the response box. Effectively, this will apply our predefined CSS styles for headings in our web page with the response content class. So that means if you want to stylize your LLM outputs differently than mine, these styles will be what you want to hack around with. Now in the script tag, create a new variable named current responses to be a dictionary with keys for each LLM and an empty string value attached to them. After checking if the data chunk is not our complete token, we can remove the line adding the raw text to the response element. Now we will accumulate the generated tokens to the current responses dictionary. Then we will render the response at its current state in Markdown in the response element. When we click our send button, we need our send prompt function to clear the responses from the newly created current responses dictionary. Then we can move the socket send call to after the responses were reset. With that done, when our responses stream, our front end will automatically convert the markdown in the LLM responses to a clean HTML and CSS formatting for our response boxes. Now we have our site at a state where it has a clean user interface. We have one more important feature to add to wrap up this web app before deploying it on a production server. Let's now implement our upvote system to give a button in the front end that allows us to save the best responses in an SQL database on our backend server. For the upvote system, let's first open up the models.py file in the Arena app folder. Here we will create a Django model, aka SQL table, by creating a class named upvoted response that takes the model class from the Django DB models library as input parameter. Inside this class, we can create the rows for our SQL table as Python variables. At the end of our class, we will define a variable named _str__ that takes self as input. This function will return the LLM name and timestamp. Save the models.py file, then open your LLM stream HTML file where we will add the thumbs up button in the front end. Start by adding the CSS styling for the thumbs up button. At the bottom of our JavaScript, we first need to create a new function named getCookie. The code here in our getCookie function will be used to get our CSRF token. CSRF tokens are unique encryption keys created by our Django server for each new user session by a web browser. Whenever we load the main page of our website, the Django backend will send a unique CSRF token that the browser will store in a cookie temporarily. When our code calls the getCookie function, we are able to extract and return the CSRF token to be attached to our request to our backend server. Whenever we send data in a request to our backend server, it will be first encrypted before sending to our backend server, and then if the CSRF token matches the expected token on the backend, it will then be decrypted before being processed and then sent back to our front end in an encrypted format, relying again on the CSRF token to decrypt the data in the front end. Encrypting your request with CSRF tokens is a standard for creating secure web applications that prevent a hacker from intercepting useful data in the web packets being sent over our web connections. Above the getCookie function, we can create another function named upvote that takes LLM as an input parameter. In the new function, create a variable to extract the prompt input value. Then add another variable to extract the current responses value matching the LLM that was input to the upvote function. Next, we can run a fetch request to our backend server with a post method. We'll pass the header's content type as JSON. Then for our XCSRF token input, we can get the result from our new getCookie function specifying CSRF token as the name of the cookie we want the browser to extract. For the body of our fetch request, we will format the LLM name, prompt, and upvoted response in JSON. After the fetch request, we can use a JavaScript then handler to parse the data which will be sent to the front end from our server in response to each of our requests. If the status back from the request equals success, create an alert in the browser confirming it was upvoted successfully on our backend. Else it was not successful, so we will alert that the fetch request failed. Now let's add the thumbs up button within the body of our HTML. In each response box within the response, add a button with the class of thumbs up button, the on-click action to call the upvote function, passing the correlating LLM name as input, and setting the area label to upvote. Now we will use a site called Font Awesome to get the free SVG code for our thumbs up icon. On the site, search for thumbs up, then click the one without the pro badge and simply click the code to copy it. Back in your button tag, paste in the SVG code and add the class of thumbs up icon to the SVG code. Then we can copy the entire button tag and paste it in the other 3 response boxes, changing the upvote input parameter to the correct LLM name for each response box. Now let's open the views.py file and add a view to send our web request to. Since streaming isn't necessary, we will create a view to handle our upvote host requests. Let's start by importing the libraries that we will use, including our upvoted response model. Below our LLM stream view, set a temporary decorator as CSRF exempt before defining the view as upvote response, taking request as input. We will implement the CSRF token generation and validation on the backend server when we deploy our site in production. Since we will only be running the site locally in development, encryption is not yet necessary. In the function, start by checking if the request method is post, and if so, we can extract all of the data from the request. Then we can select the LLM, prompt, and upvoted response. In a variable named upvoted response, we can create the row object for our SQL table. Then we will call the save function on our row object. When all of our code in the if statement finishes without any errors, return status success. Outside of the if statement, code will only run if the post request failed or it was not a post request, so we can return fail with the status 400, indicating a 400 error on our backend server. Now we have the view to save our upvoted responses. The next file we need to add code to is the urls.py file. In here, we can add a URL destination for the front end to send our upvote request to. When we send a request to this URL path, it will route the request to our upvote response view that we just created. Then we need to connect the static files for our admin site. Import these 2 libraries to your URLs file. Then we will check if debug is true in our settings, indicating the site is being ran locally and not on a production server yet, which will require a different implementation for our static files in production. And if it is still in debug mode, we can set the URL patterns for our static files within the urls.py file. Now our site has all of the front end and back end code for our upvoting system. But at the start of the video, you may remember me showing the admin view of my completed site. One of the reasons we are using the Django framework is it automatically creates back-end admin interfaces for our websites. This allows us to view and manage data for our sites in the browser by logging into an admin account. Django has already created our admin site. Now we need to create an admin account to log in with and then add our upvoted response model to be displayed within the admin interface. Open your command line with the current directory as the outer Chatbot Arena folder. Run Python 3 manage.py create super user. Then fill in your details with the username. If you desire, you can link an email and then create your password for your admin interface. Now run the make migrations command to create all of the database tables. Then run the migrate command to run the SQL commands to save our admin account details. Now let's add the upvoted response model to our admin interface. To do so, open the admin.py file in your Arena app folder. Inside the code, we can import the upvoted response model, then we can register our model to the admin site. The last file that we need to update to fully implement our upvoting system is the settings.py file in the inner Chatbot Arena folder. Scroll down to your static URL variable and put a slash in the string as the first character. Below it, we can set the static root for our site's static files, and we will also set a variable named static files dir as well as static files finders. Save your settings.py file. Then open your terminal and run the Django collect static command. This will load all of the files for your admin site into a folder named static files. After restarting the server, we can upvote responses in our Arena app. We can now also visit the /admin URL for our site and log into the admin interface where we can view and edit the rows in our upvoted response model from the browser. At this stage, we have completed local development. If you don't want to be able to access your site from any device, you can start your web server and use it locally without ever needing to pay for a cloud server. I'll now show how we can take the Django web app and deploy it on a production VPS to be hosted at a public domain for us to use from any device connected to the internet. In production, we'll make our Arena app login protected so that only people you give permission and create accounts for them can use your Arena app. For production, we will be using two paid services, a virtual private server provider and a domain name provider. For disclaimer, neither of the services shown in this tutorial are sponsors or affiliates of AI Austin. Both options I choose have dozens of competitive alternatives you may prefer to use. If you have a preference for a VPS or a domain provider, feel free to not use my recommendations as the choice is subjective here. For my VPS, I will be using vulture.com. They have the most competitive pricing that I have found and a very simple user interface for quickly deploying your new servers and easily calculating your expected server spendings. After creating and logging into your Vulture account, you'll first want to set up your payment method. If you are using a debit card, use the PayPal option since the credit card option only accepts credit. Back in our dashboard, we can now click to deploy a new server. For the lowest cost server instances, we can select the shared CPU cloud compute option. You will want to select a server location that is closest to your geographical location. For the operating system, select Ubuntu and choose the latest LTS model. For compute power, I would recommend one CPU with 1 GB of RAM minimum. That is what I will be using, but since we are using async streaming, you will notice performance benefits on the 2 CPU, 2 GB RAM server. In the next step, we will manually back up our code with GitHub, so I will disable Vulture's auto backups, but there is certainly benefits to leaving auto backups on, one being that if your server ever has a catastrophic failure, your upvoted responses have a backup for redundancy, so make this choice for your own needs. Set the name for your server and then click Deploy Now. After clicking deploy, you should see the server status as installing. This will take up to 5 minutes to install the Ubuntu operating system. And once the status shows running with a green play button, click on the server to open the settings. Copy the IP address for your server, then open your terminal for Mac and Linux users or PowerShell as admin for Windows. Inside, run SSH root at your IP address. Then back in your Vulture server settings, copy the root user password and paste that back into your command line and hit enter to SSH into the server where we will effectively be now running a remote command line to our server. Now we can start getting our server ready to deploy our web app. First, run the apt update and upgrade commands to run any updates for your Ubuntu operating system. Then we will create a non-root user that will be how we SSH into our server in the future. Save your username and password somewhere secure. After creating your user, run this command to add it to the sudo group, allowing you to now run sudo commands from the new user. Next, we will run through this list of commands to set up our firewall and enable all of the ports necessary for our web app. Now we can run this command to install Python on our server. Then we will install Nginx, which will be the reverse proxy that we encrypt all of the data sent to and from our web server before processing it to the Daphne server. Next, we will install Postgres, which will be the SQL database language we convert our models to use in production instead of the current SQLite. To set up our Postgres database, open the Postgres shell with this command. Inside of the Postgres shell, we can create the LMArena database and we can create the user for our database. Again, keep the username and password secure where you can copy it later for your code. Then run these 4 commands to properly set up your user for the web app. Now type \c LMArena and hit enter to connect to the new database. Grant all privileges on schema public to your username, and we can now exit the Postgres shell by typing \q. Our next step will be to create a private GitHub repo for our web app's code. Before we do so, if you didn't know, you should never push code to GitHub with API keys in your code. In our LLMfunctions.py file, delete the API keys from your code if you are not already using environment variables. Also in the settings.py file, delete the insecure secret key, and later we will generate our own to be stored as a system variable for a more secure method of a secret key for our Django project. Now, if you don't have a GitHub account, create one and log into your GitHub. Once logged in, create a new repo for your project, and I'd recommend changing your repo to private before clicking Create Repository. To check if you already have Git installed, in Terminal for Mac and Linux or PowerShell for Windows, run git -- version. If installed, you'll see it print your version of Git installed. For anyone that does not have Git installed locally, here's the instructions for Mac and here's the instructions for Windows. Now we need to create a local Git repo to push to our GitHub. With the current directory of your terminal at the outer Chatbot Arena folder, run git init. Then we can run git add period to add all of the files in the folder to our Git repo. And we can commit the new files, meaning save the changes as a commit in our Git repo. Now, in order to push this commit of the local Git repo to our GitHub, you have to configure your GitHub account on your PC. For this, we need a GitHub personal access token. In your GitHub account, click Settings, then Developer Settings at the bottom left. Click Personal Access Tokens and select the Classic option. We can generate a new token and click the box to enable repo permissions and create the token. Since you will not be able to view this token on GitHub in the future, copy it and store it somewhere secure on your PC. Back in your command line, run git config global username and put your actual GitHub username in a string. Then do the same for your GitHub email address. To create your Git credentials file for your personal access token to be stored, run this command on Mac and Linux, and on Windows it will be the same command, but your path should look like this with your actual Windows username. Now we can add our GitHub personal access token to the credential file. Run this echo command replacing username before the colon with your actual GitHub username. Then after the colon, paste in your GitHub personal access token. For the file path to echo to, put the path you created the file at in the last command. Now with our GitHub accounts configured, we can run these 3 commands to push our initial commit to the GitHub repo. We can now clone the GitHub repo to our server to get all of the code onto our VPS. SSH into the non-root user you created for your server. Then we will run through the same commands we just did locally to configure our GitHub account with the personal access token on the VPS. After configuration, we can simply copy the link to our private GitHub repo, then run git clone and paste in the link to the repo. Now that our Django project is on the server, we need to make a few adjustments for production. I'll be using the VS Code Remote SSH plugin to modify the code from a VS Code window. First, install the Remote SSH plugin by going to the Plugin tab, searching for it, and clicking Install. Then click the blue square in the bottom left corner of your VS Code window and click Connect to Host. In the text field, enter your username at your server IP. Then enter your password and establish the connection. Once connected, click the Explorer tab and then open the folder with your GitHub repo name. Next, we'll create a requirements.txt file for our Python dependencies. Add the dependencies the same as mine and then save this file. After that, we can open a terminal in VS Code. This will be effectively an SSH terminal to your server, and then you can create a Python virtual environment, activate it, and then install the dependencies from requirements.txt. Now you're going to need a web domain for your site. I'll be using namecheap.com to buy mine, which again is not a sponsor of AI Austin, but does have the best prices that I have found. For the lowest cost domain of $1.16 with my local taxes at the time of recording, I will use a .site domain. After completing the checkout process for your domain, click the domain list tab in your dashboard and then click Manage next to your new domain. Click the Advanced DNS tab and look for the Host Records section. Here we will add 2 A records, setting the first one with the host as @ the value as your server's IP address, and TTL as automatic. The second will be a host of www, the value of IP, and TTL as automatic. Save the changes to your domain and we can now configure our code to use the public domain instead of the local host as our domain for our website. Inside your remote VS Code window, open your settings.py file. Change the debug mode to false, which is absolutely essential essential for security and production with your Django apps. For the allowed host, add your domain, your www domain, and your server's IP address. Add a new variable named CSRF Trusted Origins and add the HTTPS links to your domain. Now we can convert the database from SQLite in the settings to now use our PostgreSQL database we created earlier. Lastly, change the static root to the actual full folder path on your server. You can right-click and copy the path to this folder in VS Code. Now for your secret key, you will need to generate a unique and secure key. For this, create a file named secret.py, and in this file, import Django's built-in getRandom secret key utility. Then print the results of calling that built-in Django function, and when you run this script, it will generate a unique and secure secret key for your project. With our secret keys generated, let's now store that, our API keys, and the Postgres user password as system variables, which is a crucial security step for all of your production web apps. Inside your Django project folder, create a new file named .env. In the file, add a variable for each of your API keys, your secret key, and your Postgres user password. Save this file, then open your settings.py file and import the load.env and OS libraries. Below the imports, initiate the load.env function. Now we can load the system variables for our secret key, and next load the password for the Postgres user and save the settings file. Open your LLM functions.py file, and same as the settings, we will import the load.env and OS libraries. Below the imports, initiate the load.env function, then you can load the API keys into your code from the environment variables. To prevent pushing the .env file to GitHub, create a .gitignore file and add .env to it. Then create a new folder in your Django project folder named static. In your remote terminal, run make migrations, migrate, and collect static. Now we'll set up our production Daphne server. Run this command to install NeoVim to edit files from your command line. Next, run this command to create and open a Daphne service file in NeoVim. With NeoVim open, press I to insert text, then type all of the settings the same as mine with your actual server username and the project path on your server. To save the changes to the file, hit your escape key, then type the :WQ command and press enter to write our text to the file and quit NeoVim. We can run these two commands to start up the Daphne service. Next, we need to configure an Nginx reverse proxy for our site. In production, we don't want to serve our static files over the Daphne server, and instead we need Nginx to serve those files. Nginx will also handle the CSRF encryption of our web requests to and from the server. Run this command to create and open the new file in NeoVim for your Nginx settings. Here you will want to copy everything the same as mine, making sure to set your actual domain where I have put mine, and make sure you set your static alias path as your actual path to your static files folder. Run this command to copy that file into the site's enabled folder on your server. For our SSL encryption, we can run this command to install certbot for Nginx. Now run this command to start up Nginx. Make sure you don't get any error messages when running that command to confirm that your Nginx setup steps were done correctly. Then we can obtain and install our unique SSL certificate with this command. Now we need to modify our LLM stream HTML file to use HTTPS instead of HTTP. In your socket variable, simply add another S to change from the WebSocket domain to the WebSocket secure domain. Then in the socket send call, add the CSRF token parameter to your request. For our server to use the static files, we need to enable the permissions for our server user with these three commands. As I said earlier, we will modify our site to require login before a user can access the Arena app. For this, create a Django admin account with this command. Then open your views.py file. Import the ensure-csrf cookie and login required packages. Above your LLM stream view, which is called every time a user visits the main page of your site, add the login required decorator, setting the login URL to /admin. Now when a user loads the main page of your site before logging into an admin account, the request is rerouted to load the admin domain, forcing the user to log in before the site will load the main page with our LMArena view. Next, add the ensure-csrf cookie decorator above the upvote response view, which will change the view to require a valid CSRF token be attached to the request before storing the responses in our databases. Now we have everything all set up for production deployment. We can run these commands to restart the daemon, nginx, and then our Daphne server. We can then use this command to view the logs for our Daphne server live. And if everything was done correctly up to this point, you can now visit your site from any device connected to the internet. Congratulations on building and deploying a production Django web app. For those of you looking to build on this project further, whenever you modify your code in the site, you can simply run through the same commands to restart your web app processes with the code changes to see them take effect. This has been AI Austin. I will see you in the next one.